January 1944. Before dawn touches Michigan's snow, the inside of Willow Run is already alive. Steel presses thunder in endless rhythm, conveyor belts hum like distant engines. Overhead lights burn white against rows that vanish into shadow. At the far end of the assembly line, men and women move with rehearsed precision, gloves tight, clipboards close to the chest. Rivet guns bite into aluminum skin without hesitation. Another bomber waits to be completed. Its fuselage gleams dull silver beneath the lamps. Workers guide wings into place using rolling jigs the size of houses. On the floor below, fresh engines are fitted directly into nacelles without pause, the propellers still wrapped like new instruments. A siren sounds. Not a warning, a signal. The shift clock marks exactly 63 minutes since the last aircraft cleared inspection. A B-24 Liberator begins taxi preparation inside the plant, not on a runway but on polished factory concrete. This is not a single plane being born. This is production measured in minutes, not months. Across the Atlantic, German intelligence officers study grainy reconnaissance photographs of similar factories and refuse to believe the figures crossing their desks. The impossible is being manufactured, again and again, and it will soon arrive in European skies. In December 1941, the world changed in a single morning. The attack on Pearl Harbor did more than pull the United States into war. It turned an industrial nation into a mobilized one almost overnight. American war planning had anticipated conflict, but no blueprint existed for the scale now required. The Army Air Forces demanded tens of thousands of aircraft, not over years but months. At that moment, the air war over Europe was already entering its most brutal phase. Britain had been bombing German cities since 1940. The Royal Air Force flew night raids using heavy bombers that suffered catastrophic loss rates. Germany's Luftwaffe remained dangerous but overstretched, dividing resources between the Eastern Front, home defense and Atlantic operations. The skies over Europe were becoming a grinding test of endurance. Every bomber lost required swift replacement, yet aircraft production on both sides lagged far behind operational demands. Before Pearl Harbor, American aircraft plants still operated on conservative peacetime assumptions. Production was handled in craft style. Teams assembled full sections manually. Parts were individually fitted. Delays were common. Quality control depended on experience rather than standardized processes. Most major bombers took weeks to assemble even after components were delivered to final plants. Few factories were capable of true mass flow manufacturing. The urgent numbers made that model obsolete instantly. The Army Air Forces had calculated that an independent bomber offensive against Germany required enormous aircraft density. To maintain sorties, cover training losses, sustain maintenance attrition, and compensate for combat destruction, bomber strength demanded continuous surging output. Early casualty rate forecasts were grim. In 1942, some bomber groups lost more than 5% of their aircraft on single missions. Losses of 20 to 30 bombers at a time forced commanders to rotate entire squadrons out of combat for replenishment. Crews trained for months and vanished in minutes. Aircraft inventories evaporated almost as quickly. Numbers were merciless. One heavy bomber equaled years of industrial labor if conventional methods remained unchanged. So American war planners turned to something they knew better than anyone else: mass manufacturing. Detroit had already proven the formula decades earlier: standardized parts, moving assembly lines, modular construction, precision logistics. Instead of craftsmen completing entire vehicles, thousands of specialized workers would handle singular assembly tasks with speed and repetition. The federal government approached the Ford Motor Company. Ford possessed what few organizations in the world had mastered: the ability to produce complex machines faster than any rival, with mechanical consistency rather than artisanal variation. Henry Ford himself had resisted war production earlier, but economics and national pressure tilted the scales. The company received contracts to construct a bomber plant of unprecedented size, not merely a hangar, but a factory capable of continuous airplane flow. The location was selected near Ypsilanti, Michigan. This facility would become Willow Run. The plan called for assembly surges on a scale never attempted for aircraft. The B-24 Liberator, then emerging as America's primary heavy bomber alongside the B-17, was selected as the production centerpiece. The Liberator was not simple. It contained over 1 million individual components. Its wingspan rivaled small passenger airliners. Its structure demanded precision aluminum tolerances that automobile stamping plants had never faced. Its engines accounted for tens of thousands of moving parts. Every hydraulic line, oxygen hose, electrical wire, and bomb release mechanism had to function perfectly across extreme temperature and vibration ranges. Initial timelines projected delays. Early production testing validated the concerns. When Willow Run launched operations in 1942, severe problems emerged immediately. Parts arrived late or mismatched. Workers trained for auto-assembly lines lacked experience with aircraft tolerances. Engineering drawings contained inconsistencies. Riveting standards differed between specifications. Fragments of Liberators piled up incomplete across the factory floor. Some aircraft remained unfinished for months. The press quietly labeled Willow Run a failure during its first operational year. But behind the scenes, transformation accelerated. Ford reorganized the assembly into flowing sublines. Wings were assembled separately and joined at precise staging docks. Bomb bay segments moved on, dedicated rails. Electrical harnesses were pre-wired off-site and installed as entire units instead of individually routed lines. Inspection protocols shifted from final assembly checks to in-process testing, catching defects earlier and reducing rework bottlenecks. The workforce expanded and adapted. By late 1943, over 40,000 men and women staffed Willow Run. Many had never worked industrial jobs before. Women took rivet and inspection roles in numbers unprecedented in aviation production. African American workers recruited from southern states joined mixed skill crews despite discrimination barriers. Training programs rapidly standardized skills across thousands of employees. The rhythms of aircraft assembly gradually synchronized with motor industry efficiency. Each station began to operate with clock discipline rather than craft pacing, and output began to climb. In early 1943, the plant produced a bomber every few days. By autumn, every day. With each quarter, the interval shortened. Lines tightened. Tasks compressed. Tool systems optimized. There was no celebration on the floor, only speed targets and new benchmarks. Because the timeline was merciless. Across the Atlantic, bomber commanders counted replacements not in months, but in days. Each convoy of completed aircraft represented potential survival for crews, averaging barely 25 years of age. Factories were now feeding the front lines directly. And among all those factories, Willow Run was quietly beginning to achieve something that would soon defy belief, not just outproduce enemies, but outpace the concept of aircraft manufacturing itself. The numbers whispered through military logistics offices before spreading outward. Soon the impossible figure would reach intelligence desks overseas, a bomber leaving the line every 63 minutes. Target length 700 to 800 words. By early 1944, Willow Run had completed its transformation from uncertain experiment into industrial machine. The factory itself was staggering in scale. Over 3 miles of continuous interior assembly floor stretched under a single roof. Sublines branched like arteries off a central fuselage spine. Rail systems carried entire bomber sections on wheeled dollies past workstations timed to the minute. Overhead cranes slid wings into position with metronomic regularity. Every movement was scheduled. The plant did not operate in shifts. It flowed. 24 hours a day, 7 days a week. When one workforce rotated out near midnight, another immediately stepped into uncooled machinery still warm from constant use. The line never stopped. Thousands of tasks were broken into sequences as precise as automotive engine assembly. One worker fastened the same 6 bolts on every aircraft crossing his station. Another installed oxygen hose clamps repeatedly for entire shifts. Entire teams specialized in nothing more than fuselage seam sealing or turret calibration. Training had shifted away from general aircraft skills into ultra-focused repetition. Work speed replaced work scope. Every technique learned from automobile production was refined for aeronautics. Precision gauges replaced eyeball fitting. Templates eliminated manual measuring. Pneumatic riveters replaced slower hand tools. Errors were hunted systematically and stamped out by redesigning workflows rather than retraining individuals. The factory became a living laboratory of mass aviation engineering. Supply chains fed this beast from across the continent. Aluminum sheet arrived from Tennessee and Washington's smelters. Engines poured in from Midwestern subcontractors. Plexiglass turrets and canopy blisters came from specialized optics plants. Radios and navigation instruments were shipped from New York and California electronics lines. Tires, hydraulics, landing gear struts, control surfaces, nothing moved casually or independently. By mid-1944, over 600 subcontractors fed components into Willow Run. Every delay anywhere meant a stall everywhere. Logistics teams synchronized rail routes and truck convoys with ruthless mathematical precision. Parts arrived within narrow windows measured in hours rather than weeks. Warehousing grew minimal. Almost everything went onto the line immediately. Just-in-time manufacture had quietly been invented. Quality discipline shifted too. Instead of inspecting finished aircraft after assembly, the Ford system tested components at station entry. Defective parts were rejected before installation, preventing late-stage repairs that stalled flow. Field testing protocols were streamlined so newly finished aircraft taxied directly from the indoor ramp to flight testing without sitting idle on outdoor aprons. The Liberator design itself underwent revisions tailored for speed production. Non-critical contours were simplified. Variants were standardized to reduce manufacturing complexity. Certain internal fittings were modularized to allow bulk installation rather than single-part placement. Over time, the bomber's engineering evolved as much for factory efficiency as battlefield survival. And slowly the numbers began to cross thresholds no one had previously imagined for aviation. By January 1944, the plant completed approximately one aircraft every 72 minutes. Managers did not celebrate. They shortened targets. New work motion studies broke tasks into second-by-second actions. Tool suspension rigs eliminated worker fatigue between components. Pre-assembly kitting ensured no worker left his station searching for parts or equipment. By March, output tightened to roughly one bomber every 70 minutes. A month later, the figure fell again. Every 65 minutes. Then finally, the barrier that had seemed theoretical was shattered. In July 1944, Willow Run registered its record rate. One B-24 Liberator completed every 63 minutes. Each aircraft represented more than 20 tons of flight-ready war machine. More than 800 finished bombers rolled off the line in that single month. It was more than Germany's total monthly heavy bomber production. It exceeded Japan's entire large aircraft output multiple times over. It astonished even Allied planners who had become accustomed to industrial miracles. Yet the context outside the factory remained lethal. Over Europe, bomber streams carved corridors across occupied France and the Ruhr Valley. Casualty lists continued to climb. A single air battle could erase an entire day of factory output from the skies. German flak batteries stitched black smoke through bomber formations. Fighters slashed at exposed aircraft climbing toward high-altitude bombing runs. Every 63 minutes of factory labor could still die in seconds over Europe. But the calculus had changed. Losses that once forced cancellation of bomber operations were now replaced within days instead of months. Entire groups of destroyed aircraft could be re-equipped faster than pilots could complete retraining. The scale of aerial pressure multiplied relentlessly. German intelligence units attempted to verify Allied production claims, captured documents, factory reconnaissance photographs, shipping manifests. The data appeared impossible. Luftwaffe analysts calculated resource constraints that should have capped American aircraft output at half the claimed rate. Their estimates were wrong. They did not account for the complete mobilization of American industrial culture, beyond mere factory count, into systems thinking, logistics velocity, and human specialization. The German war economy had prioritized craftsmanship examples, even within mass settings. American production culture embraced pure volume and iteration. Where German engineers valued perfection per machine, Americans optimized acceptable perfection multiplied by quantity. The skies would begin reflecting the result. The growing phantom of endless bomber waves unnerved Axis planners across air defense chains. Reports reference the sensation of aircraft appearing without depletion, losses from one raid seemingly erased by the next week's replacement wave. And behind that illusion of endless material lay a factory that never slept. Willow Run's lights burned through Michigan nights as crews worked rivet by rivet, minute by minute, not knowing faces or names of those who would one day fly their aircraft, but knowing that replacements would always matter. Because beyond numbers and schedules stood human weight. Each bomber built carried 10 young men into enemy airspace. Factories were no longer simply supplying war, they were shaping survival probabilities. And that human dimension, the individual cost beneath industrial success, would soon reveal itself in the many layers of the story ahead. Inside Willow Run, the war sounded nothing like artillery. It sounded like rhythm. Rivet guns hammered aluminum skins in staccato bursts. Conveyor motors whined softly under hanging fuselage shells. The echo of steel footsteps crossed catwalks above endless assembly lanes. Most workers had never seen combat. Many had never even flown, yet their labor was inseparable from the fate of men crossing European skies. The average factory worker earned steady wages for the first time in their lives. Farmers' sons from Michigan towns stood beside women recently trained for riveting stations. African-American crews worked segregated lines initially, then increasingly mixed teams as labor demands overwhelmed discrimination protocols. Language differed, backgrounds differed. All faced the same quotas. Production quotas were relentless. Posters across the plant counted aircraft by day, not by year. Numbers climbed, replaced by larger numbers almost weekly. There was pride in the metrics, yet little celebration on the floor. Output targets rose so smoothly that success felt invisible. Only failure produced attention. The emotional anchor connecting workers to the war was often personal. Photographs of bomber crews were pinned near time clocks. Letters sent from crew training bases were shared in break rooms. Occasionally, news arrived of a telegram sent but not returned, a crew that had not come home. Workers discovered the aircraft they touched might be the one carrying neighbors or relatives. Some women named the bombers quietly. Not official nose art, private memories. A riveter might write a tiny chalk mark inside a bulkhead before a panel was sealed forever. These marks would never be seen again. The labor was exhausting. 8 to 10-hour shifts became standard. Overtime dissolved weekends. Calluses split fingers until gloves became mandatory. Yet absenteeism stayed remarkably low. The product itself, an enormous plane destined for combat, gave the work a severity automobile manufacturing never could. Workers understood replacement demand intimately. They watched footage of aircraft losses in factory newsreels shown during meal breaks. They read casualty figures in daily papers. When a bomber crash destroyed an entire crew, most of the plant knew that somewhere along the line, the replacement aircraft was already in assembly. The scale of production numbed the senses. Hundreds of workers might touch a single aircraft without knowing its fate. But each station carried quiet accountability. Rivet integrity, electrical harness routing, fuel line sealing. A single oversight could doom a crew above hostile territory. In those moments, the assembly line ceased being a machine. It became a human chain linking worker fatigue to pilot survival. And workers moved faster each month. Not because of slogans alone, but because delays translated directly into pilots waiting without aircraft. Every minute counted, which is precisely why the tactical logic of bomber warfare magnified this production miracle. By mid-1944, Allied bombing strategy demanded consistent saturation, rather than episodic raids. Earlier bombing campaigns suffered from fragile force density. Aircraft shortages meant missions flew intermittently, allowing German air defenses to recover and reposition between raids. Fighter escorts lacked numbers. Bomber formations often launched thinned and exposed. American doctrine evolved toward sustained pressure. The goal was to fly massive daylight bomber streams into Germany repeatedly, overwhelming fighter interception and saturating flak coverage to reach industrial targets. Success depended not on a few daring missions but relentless repetition. That required numbers above all else. A bomber lost today had to be replaced before tomorrow's mission window. The production flow from Willow Run, along with parallel plants like Douglas in Tulsa and Boeing in Washington, made that tempo possible. Entire wings could be rebuilt within weeks. Aircraft staging fields in England began filling faster than training units could produce crews. Bombers waited lined nose to tail on muddy airstrips across East Anglia. Maintenance depots rotated damaged aircraft back into service at accelerating rates as supply lines stabilized. German intelligence officers noticed patterns. Early 1944 losses during major raids over Regensburg and Schweinfurt had failed to reduce bomber presence. Instead, American formations grew in density week by week. Mission sizes doubled. Escort coverage thickened. German fighter pilots no longer found empty skies between raids. Bomber waves arrived consistently, and every wave required continuous replacement to keep pressure stable. Willow Run enabled strategic continuity. It transformed losses from strategic setbacks into logistical inconveniences. For the first time in the history of aerial warfare, numerical replacement effectively neutralized enemy attrition capacity. Where Germany and Britain had earlier bled aircraft faster than they could be replaced, the United States reversed the equation entirely. Bombers became consumable assets. Not because crews were expendable, but because airframe loss was no longer strategically fatal. Production had outraced destruction, and that superiority depended on more than manpower and logistics. It was built on technological standardization done specifically to serve volume. The B-24 Liberator was engineered with manufacturing in mind more intentionally than any prior heavy bomber. Unlike the hand-built aircraft of earlier generations, the Liberator used extensive straight-line structural elements, reducing complex curvature in metal forming. Its wings employed a high aspect ratio Davis airfoil which, while aerodynamically advanced, also allowed sectional assembly of wing panels rather than continuous sheet contouring. Panels from multiple subcontractors matched standardized tolerances tightly enough to fit without handshaping on the line. Rivet patterns were stencil mapped to drilling guides, allowing semi-automated guns to place fasteners consistently without individual judgment calls at every station. Hydraulic fittings were standardized across variants. Electrical looms were prefabricated. Each design decision shaved seconds from installation times. Seconds multiplied by thousands of tasks per bomber became hours saved per aircraft. Hydraulic testing jigs allowed entire systems to be pressure tested before fuselage installation. Engines were hung as finished modules rather than component build-ups on the line. Bomb bay assemblies slid into place almost as sealed units. In contrast, German bomber plants still relied heavily on manual fitting. Skilled metalworkers shaped and adjusted airframes to individual tolerances, valuing craftsmanship over speed. Repair cycles overloaded factories, producing both new aircraft and rebuilding damaged ones from the front. Every deviation reduced throughput. American engineers favored uniform imperfection over perfect uniqueness. The aircraft were not built to artistic standards. They were built to fly. The philosophy was brutal but effective. Acceptable tolerance multiplied by mass became battlefield supremacy. At Willow Run, aircraft were not masterpieces. They were statistical weapons, which framed a profound contrast between leadership cultures driving each nation's war industry. The success of Willow Run did not emerge from singular genius. It came from conflict between vision and reality. Henry Ford's industrial theory championed efficiency at almost ceremonial levels, yet early Willow Run failures exposed the limits of automotive manufacturing applied blindly to aviation. His leadership struggled initially to reconcile factory flow speed with aircraft precision demands. Military inspectors repeatedly halted lines over improperly installed systems. Quality benchmarks clashed with output goals. The breakthrough arrived when management ceded engineering authority to integrated military industrial planning. Plant leadership adopted a ruthless data-driven discipline. Stopwatches timed each workstation. Inefficiencies became mathematically documented. Supervisors reorganized teams hourly when work sequences drifted off cadence. Departments posted throughput metrics publicly to foster competition among lines. Workers were no longer grouped by skill alone, but optimized by movement patterns. Leadership invested heavily in standardized training modules that reduced reliance on individually experienced craftsmen. Learning curves flattened across the workforce. Crucially, decision-makers abandoned micromanagement hierarchies. Problems reported by line workers were assessed rapidly by on-site engineering teams, empowered to approve redesigns without waiting for distant executive review. If a hydraulic fitting caused delays, alternative securing methods were tested within days. Failure ceased to be punished and became used. Not for discipline, but for diagnostics. Production leadership treated the bomber as a process problem rather than a sacred artifact. The aircraft's purpose came first, not reverence for design purity. Even personal leadership adapted. Plant managers rotated through night shifts, walking floors at 1 in the morning to identify bottlenecks directly. Human oversight mattered less for authority and more for responsiveness. These behaviors, data-driven adaptation, speed of correction, decentralization of problem-solving, formed the invisible architecture of Willow Run's acceleration. America did not win the industrial war by hero worship. It won by institutional flexibility. But the significance of that flexibility reached beyond American factories. Across occupied Europe, observers struggled to understand what they were facing. German intelligence officers, examining Allied production data, were baffled. Pre-war German industry emphasized technical excellence over throughput. Factories remained smaller, specialized, and dependent on skilled artisans. Aircraft were assembled in dispersed facilities deliberately to protect against bombing, but this fragmentation complicated logistical coordination. Bombing destroyed rails. Missed deliveries crippled subplants. Parts shortages forced idled production lines. German output became unpredictable, even as engineering designs remained exceptional. When Luftwaffe intelligence agents reported that American factories were producing multiple heavy bombers per day, per factory, analysts simply refused the conclusions. Computational models using German industrial benchmarks said the numbers were impossible. The calculations failed to include total system efficiency. In Germany, raw materials moved intermittently. Work schedules were irregular due to air raids and energy shortages. Labor pools shrank as conscription and bombing casualties drained manpower. Skilled craftsmanship meant limited substitution when experienced workers were lost. America had inverted that entire equation. It possessed abundant raw materials, secure continental transport routes, protected power infrastructure, and labor expandable through training programs, rather than apprenticeship traditions. When reconnaissance photos finally revealed the scale of installations like Willow Run, disbelief turned into strategic alarm. German leadership debated exaggerated rumors of infinite bomber reserves. Some officers warned industrial collapse in the face of unstoppable bomber production. Others dismissed the threat as propaganda. Meanwhile, frontline airmen noticed truth firsthand. Every pilot knew aircraft shortages intimately. German repair units were cannibalizing wrecked planes to keep others flying. Fighters grounded for lack of parts accumulated across airfields. Yet overhead, Allied formations expanded. Bomber streams grew longer, deeper, thicker. Escort fighters now outnumbered defenders over German airspace. And losses seemed not to reduce Allied strength at all. The perceived infinity of American manufacturing became psychological warfare. Morale faltered. Pilots reported arriving to meet fresh formations each sortie, never less than before, often dramatically more. Operational planners were forced to divert defensive assets simply to survive the growing sky density. Germany had not been technologically defeated. It was being industrially drowned, which raised a deeply unsettling dimension to the narrative, one that extended beyond tactics or leadership. At Willow Run, victory was measured in aircraft completed. At airfields across England and Italy, Victory was measured in letters sent home or not sent at all. Each bomber carried 10 crew members, pilots, co-pilots, navigators, bombardiers, radio operators, gunners. Many were barely into their 20s. They boarded airplanes knowing statistical survival odds of completing 30 missions hovered near 50%, sometimes lower. Mass production saved operational tempo, but it did not save individual lives. The bomber offensive remained one of the most lethal assignments in the entire war. Casualty rates rivaled frontline infantry units. Entire crews vanished without remains recovered. Survivors returned psychological wrecks from endless flak corridors and fighter attacks. Factories replaced aircraft faster than air forces could train crews. Pilots became the limiting factor. Training programs accelerated dangerously to meet output, sometimes reducing flight experience hours before deployment. Young aviators arrived in combat theaters with minimal combat readiness, thrust immediately into the maelstrom. The industrial miracle created a moral ambiguity. Manufacturing power made it easier to sustain attritional warfare from a logistical perspective. But every additional aircraft meant another crew exposed to near-lethal probability. Victory was increasingly automated. Human cost remained personalized. For factory workers, the connection grew sober with time. Many no longer celebrated milestones once casualty lists circulated weekly. The triumph of 63-minute bombers came paired silently, with growing walls of names in combat memorial briefings. Yet most of the workforce kept working. Because replacement meant survival, not only in material terms, but in preserving the pressure that would shorten the war itself. Attrition accelerated final victory. The moral weight hovered unspoken. Was speeding production saving lives by ending war sooner, or was it multiplying sacrifice? History still debates, but quietly. But for men stepping into cockpits each dawn, the debate mattered less than this single truth. They depended on a factory thousands of miles away to keep the airframe around them intact. Their fate flowed upstream to tiny rivets fastened by hands they would never meet. And eventually their survival or loss flowed back down into statistical reports that shaped leadership decisions well removed from any cockpit. Which brings the story forward to the pivotal moment when all the production numbers turned into visible battlefield transformation. The moment when the scale reached irreversible force. The summer of 1944 marked the moment manufacturing supremacy became air dominance. By June, the Allied invasion of Normandy had already broken into continental Europe. Every beachhead convoy and armored push depended upon constant air cover. Bomber groups were no longer focused only on deep industrial raids. They were now tasked with destroying rail hubs, troop concentrations, artillery emplacements, and communication corridors across France and Western Germany. This escalation required unprecedented sortie volume. On paper, Allied air planners estimated they would need over 15,000 heavy bombers operational to sustain pressure across multiple fronts. Attrition calculations assumed thousands of aircraft would be lost before the year's end. Yet replacement inventories continued to outpace losses. The tipping point arrived in July at Willow Run. Records confirmed that the plant had crossed its ultimate production threshold, completing one B-24 Liberator every 63 minutes across full continuous operations. At peak rhythm, finished bombers rolled off the assembly line at a rate approaching 23 per day. Airfields in Michigan, Kansas, and Florida overflowed with newly finished aircraft awaiting ferry pilots. Across the Atlantic, reception fields in England recorded deliveries exceeding maintenance intake capacity. Formation sizes visible over Europe doubled within weeks. German air intercept units reported contact with bomber streams, numbering up to 2,000 aircraft per raid, waves stretching from horizon to horizon. The United States Army Air Forces reorganized bombing doctrine accordingly. New mission plans layered bomber boxes deeper and wider, deliberately saturating flak zones so dense formations reduced individual vulnerability. Escort fighter wings now accompanied bombers from coastal approach to target return, no longer retreating halfway due to fuel limitations thanks to long-range fighters arriving in mass numbers. Aircraft supply was no longer a constraint. Operational imagination expanded. Commanders authorized repeat strikes against hardened industrial targets previously abandoned as too costly. German oil facilities, synthetic fuel plants, and underground factories faced relentless consecutive raids. Every raid that previously would have grounded bomber units to rebuild strength now barely dented overall operational numbers. Losses ceased being visible. Production erased them. Crews rotated through mission cycles at breakneck tempo. Ordered into 12-hour readiness alerts. Launched, recovered, debriefed. Neighbors' empty bunks were filled by replacement crews flown in almost immediately. In 1 month alone, July 1944, American bomber groups absorbed over 600 aircraft losses and replaced them completely. The sky did not grow empty. It grew fuller. Across German air command channels, emergency directives redirected fighter units from frontline support exclusively into homeland interception roles. But the numbers favored the attackers. Even elite Luftwaffe pilots flew daily against enormous formations while facing escort fighters that no longer disengaged. Survival expectancy plummeted. Germany attempted countermeasures, rocket interceptors, jet fighters, concentrated flak corridors, yet none matured fast enough or in sufficient quantities to stem the tide. Every technological innovation faced one unbridgeable obstacle. Production lagged behind American volume. Jet fighters were revolutionary, but a dozen jets could not break 1,000 bomber formation. Rocket interceptors scored individual downings but consumed irreplaceable pilots at unsustainable losses. Germany still fought with excellence. America fought with multiplication. And that multiplication traced directly back to factories like Willow Run. Army Air Forces command documents from August 1944 referenced continuous bomber availability for the first time in operational language. Previously, sortie planning had included aircraft conservation margins. Those margins disappeared. Bomber supply had become effectively inexhaustible relative to attrition rates. For air planners accustomed to fragile force preservation throughout earlier air wars, the strategic shift felt extraordinary. They were now operating from abundance rather than scarcity. Target lists expanded. Tempo increased. War compression accelerated. Meanwhile, within the factories, the pace barely changed, because it had already been maximized. Workers did not celebrate battlefield breakthroughs. They still clocked in, still riveted. Still sealed rivet seams, calibrated sour turrets, fitted oxygen regulators, torqued engine mounts. News arrived only via radios crackling overhead, and black bold newspaper headlines pinned near brake drum boards. Victory felt distant. What workers did grasp instinctively was intensified urgency. Requests from air groups for rapid modifications reached factories faster than formal orders. Heated cabin vent changes. Armament mount reinforcements. Structural reinforcements around wing spars. Forward teams integrated field feedback directly into micro-adjustments on the line without halting output, a feat once thought impossible. Every day was iteration layered onto relentless production. The Liberators, being assembled in late summer, were not the same machines that left the line in winter. They were tougher, marginally safer, and still being produced in virtually unchanged timeframes. This dynamic locked the war's turning engine into place. Not through a single battle or tactically decisive dogfight, but through the systemic saturation of the enemy's capacity to adapt. By late August 1944, German synthetic fuel production had collapsed under sustained bombing. Aircraft training exercises were curtailed due to fuel shortages. Interceptor squadrons were forced to ration flight hours. Skill degradation followed. The vicious cycle set in. Factories supplied bombers. Bombers destroyed fuel. Fuel shortages grounded fighters. Grounded fighters reduced resistance. Resistance collapse increased bombing efficiency. And every cycle shortened the war timeline. But the full psychological impact of unstoppable bomber numbers would emerge, not in strategic documents, but in the testimony of defeated airmen themselves. For those German pilots who survived the storm, the memory they carried was not of specific battles. It was of endless aircraft. Aircraft they could not outrun, cannot outshoot, cannot exhaust. a sense that something immeasurable had turned against them. And that sense would sharpen dramatically during the next phase of the air war, when American industrial volume now met its final battlefield test. Target length 750 to 900 words. By early September 1944, the air war's arithmetic had become stark. Bomber streams no longer represented tactical waves. They resembled aerial tides. German radar networks detected incoming formations hours before contact, yet interception preparedness barely mattered. Warning time did not alter the outcome. Fighter groups lacked fuel to launch full-strength responses. Trained pilots were too scarce to man cockpits, even when aircraft were available. Ground artillery crews fired until barrels glowed from heat. Ammunition stockpiles dwindled faster than replenishment trains could arrive. Flak density rose, but so did bomber density. Every shell fired statistically mattered less. Aircraft fell, but less noticeably. American commanders initiated the most punishing campaign yet, massed strikes on Germany's remaining oil heartland. Targets at Luna, Merseburg, Ploiești's auxiliary refineries, and Ruhr hydrogen plants were hammered repeatedly. Each strike involved bomber formations numbering in the thousands, supported by escorts flying from recently liberated continental airfields that shortened flight distances and increased escort leg endurance. The Luftwaffe scrambled every remaining experienced unit. Jets from newly equipped squadrons intercepted select formations with startling speed, achieving tactical successes. But numbers nullified breakthroughs. Each engagement downed multiple Allied aircraft, yet the formations kept coming. Within weeks, German fuel reserves hit crisis levels. Training flights ceased almost entirely. Fighter replacement pilots were sent aloft with minimal flight hours, sometimes fewer than 50 total. Air battles turned into slaughters. Young German aviators died within their first sorties against veteran Allied escorts, whose numbers now blanketed entire sectors of sky. The illusion of industrial impossibility fractured. Enemy pilots came to believe that American manufacturing had become functionally infinite. German post-war interviews often used variations of the same phrase. The bomber waves never thinned. Even during major interception efforts that inflicted severe losses, reconnaissance flights soon identified new bomber groups replacing the fallen. Late summer intelligence intercepts recorded frustrated German command exchanges over inability to degrade Allied air strength. Attrition targets were no longer attainable. The victory condition had slipped away. On the American side, combat losses remained heavy, but survivorship narratives began to change. Completion of mission tours became frequent enough to be celebrated. Crews painted tallies on fuselages rather than mourning missing brothers immediately. Escort fighters reported achieving full air superiority over wide segments of Germany for the first time in the war. The sky, once contested territory, became Allied-controlled airspace. All of this rotated back on the engine of production. Willow Run's 63-minute rhythm sustained frontline transformation invisibly. For every Ploiești raid-destroyed bomber, another aircraft completed assembly while riveters changed shifts on Michigan soil. For every experienced crew lost, 2 more trainees boarded transports after line delivery schedules met training quotas. The attrition gap closed. What had once been an equation of sacrifice became an equation of inevitability. By October 1944, German aircraft production, despite heroic dispersion efforts, had collapsed under combined bombardment and material shortages. Even jet manufacturing plans stalled as steel shipments slowed, and factory power outages became routine. Meanwhile, American output continued to rise across multiple aircraft categories: bombers, fighters, transports, reconnaissance planes. Industrial momentum irrevocably tilted westward. No battlefield reversal existed that could undo it. As the European winter approached, Allied armies advanced behind air cover that now hovered continuously overhead. German ground columns moved only by night to avoid destruction. Rail transportation had degraded to near paralysis. Oil stockpiles dwindled toward extinction. The machinery of war no longer ran. Not because soldiers had stopped fighting, but because factories had been obliterated faster than they could be rebuilt. October reconnaissance photos over bombed refinery complexes revealed twisted structures still smoldering weeks after last strikes. The outcome now was arithmetic rather than tactical. Germany could not build aircraft faster than America could destroy what little fuel remained to fly them. History had crossed a point of no return. The climax had arrived not as a dramatic single siege or collapse, but as a silent realization spreading across both sides. One side saw continuous possibility. The other saw eventual exhaustion. There were still battles left to fight. Airmen would still die. But the strategic question was no longer whether Germany could resist. It was how long resistance could last. That recognition echoed quietly through Allied command to factory shop floors and back to air bases preparing next day's sorties. The entire war machine leaned forward together. Mass production had evolved into mass inevitability. And yet the final questions of victory only materialized fully after the noise of combat faded, when numbers became consequences and lives became statistics tallied under the relentless weight of outcome. Those consequences would define the last chapters of the story. Target length 600 to 700 words. By the spring of 1945, the air war's verdict was unmistakable. Germany's ability to contest the skies had largely collapsed. Fighter operations became sporadic, increasingly limited to desperate point defenses around isolated industrial remnants. Training programs were effectively non-existent. Fuel rationing had cut flight hours to minimal maintenance checks. In some units, pilots drove trucks during daylight hours to preserve aviation fuel for potential emergency sorties. Meanwhile, the Allied bombing campaign reached its final crescendo. Rail junctions, bridges, synthetic fuel plants, marshalling yards, and remaining aircraft assembly facilities were struck with methodical thoroughness. Bomb tonnage dropped across German territory, reached historic levels. Entire transportation regions became impassable, stalling troop redeployments and leaving armored formations immobilized without resupply. The bomber offensive exacted terrible cost. Between 1942 and the war's end, more than 26,000 American aircrew died in the European theater alone. Tens of thousands suffered injuries or were captured. Average crew mortality rates hovered near 50% for heavy bomber groups early in the campaign, gradually declining only after air superiority was secured. Aircraft losses mirrored the human toll. More than 18,000 American aircraft were lost in combat across Europe. Bombers, fighters, and support craft combined. Liberators bore heavy attrition alongside B-17 formations, often flying low-altitude fuel and transport interdiction sorties that brought them deeper into flak corridors. Yet, despite these staggering losses, the replacement machine remained inexhaustible. Willow Run itself completed over 8,600 B-24 Liberators before war's end, more than any single factory ever produced of one aircraft type. Nationwide, the United States built nearly 300,000 military aircraft across all categories during the conflict. Numbers unimaginable only years earlier. The personnel dimension translated into vast civilian mobilization. Over 2 million American workers became employed directly in aircraft manufacturing during the war years. Women comprised nearly half the factory cohorts at peak production. African American workers gained industrial footholds that reshaped post-war labor access despite entrenched segregation barriers. Economic landscapes transformed. Small towns near aircraft plants evolved into industrial centers almost overnight. Housing developments expanded rapidly to accommodate workers. Training schools proliferated to support specialized technical instruction. Childcare programs arose, still rare at that time, to sustain continuous shifts. Willow Run even constructed its own housing complexes, medical clinics, and transit systems. War reshaped the civilian experience as deeply as the military front. As German resistance collapsed through early 1945, Allied ground units advanced under overwhelming air cover. Columns moved openly under blue skies without fear of Luftwaffe interference. Roads long targeted by bombers now carried advancing formations toward the Rhine. Factories responsible for sustaining German war production lay in ruins. Aerial reconnaissance from March 1945 showed refinery outputs at near zero capacity. Rail junctions appeared pulverized. Half-finished aircraft littered bomb-damaged hangars amid scattered toolsets, abandoned by workers fleeing bombardment. The industrial backbone sustaining German resistance had been dismantled systematically. For Allied commanders reviewing operational histories after Germany's surrender in May 1945, a consistent conclusion emerged. Air superiority, created by the marriage of manufacturing scale and tactical doctrine, had shortened the European war dramatically. Before Willow Run reached full production, the bomber campaign remained a gamble. After bomber availability surged, sustained pressure became inevitable. Factories had not merely supplied aircraft, they had reshaped strategic outcomes. Yet as oceans of numbers filled official reports, another reckoning unfolded quietly among veterans and laborers alike. People began naming the lost. Photographs replaced production graphs. Former riveters gathered at memorial ceremonies remembering the crews who flew the aircraft they built, sometimes discovering names matched faces of neighbors or relatives long presumed anonymous to the war effort. Victory had arrived, yes, but it arrived weighted with absence. The final dimension of the story, the long shadow of what this industrial miracle meant for humanity itself, only revealed itself when the machines were silent and peace forced reflection forward. Target length 600 to 700 words. When Germany surrendered in May 1945, the skies fell silent with almost unnatural speed. Runways once crowded with scramble alerts and recovery landings sat empty. Bomber groups stood down. Engines cooled at last. At Willow Run, the assembly line continued briefly, fulfilling final contractual obligations, but the tempo slackened within weeks. 63-minute intervals stretched back into hours. The pressure that had dictated daily existence dissolved without ceremony. Workers were laid off gradually. Some returned to farming towns. Others took newly available manufacturing jobs building automobiles, re-entering civilian markets. Many women who had mastered riveting, inspection, and electrical harness installation were quietly pushed out of industrial positions as men returned from overseas. The wartime labor revolution faded faster than it had risen, yet its imprint remained. Technical knowledge gained during mass aviation production seeded the post-war aerospace industry. Engineers who refined production flow at Willow Run later played roles in jetliner manufacturing, space program developments, and automated assembly architecture. Concepts like modular installation, sub-assembly logistics, and inspection at origin became permanent industrial fixtures. The effects radiated outward. America emerged from war with the largest aircraft manufacturing infrastructure in the world. Within years, this capacity transitioned into civil aviation expansion, passenger airline fleets, cargo aircraft networks, weather reconnaissance planes, scientific research platforms. The same methods that once fed bomber squadrons would later carry civilians across oceans. Germany faced a darker industrial legacy. Most experienced engineers were either captured or scattered. Factories lay gutted. Materials shortages spanned years. Aircraft development stalled completely until late reconstruction stabilized at minimal levels. Industrial recovery lagged behind political recovery. The continental production asymmetry remained into the Cold War era. Yet beyond these economic consequences lay deeper psychological shadows. Many Willow Run workers later struggled privately with the moral implications of their contributions. They had built machines designed explicitly for destruction. Some embraced pride, believing their labor shortened the war and saved countless lives. Others questioned whether acceleration of industrial killing set precedents that extend even today, where automated warfare measures success more in tonnage produced than human lives spared. Veterans carried parallel burdens. Survivors from bomber crews aged with memories of flak detonations, cold oxygen mask breathing at high altitude, and friends who never returned. Psychological wounds lingered long past victory parades. The scale of production that had saved missions had also dulled the individual value of aircraft losses. Airframes became replaceable. People never were. Those truths sometimes collided during reunions. Former mechanics would describe rushing to solve oxygen line seals or turret alignment deadlines. Veterans would quietly recount mid-air explosions or burning descent paths. Each side realized how intimately their wartime experiences were connected, despite never having met during the conflict. And standing between them was Willow Run itself. The factory was shuttered long after the war, eventually converted into a museum space preserving its cavernous halls. Empty floor stretches now host silent aircraft displays, far smaller than wartime inventory. Visitors walk past objects that once symbolized relentless urgency. Now they symbolize something else: capacity. Human capacity to mobilize. Human capacity to coordinate millions into one purpose. Human capacity to harness industrial systems so large that they determine global outcomes. The museum tours do not dwell solely on triumph. They speak of transformation, of how warfare shifted permanently. After 1945, victory would no longer hinge merely on battlefield heroism. It would hinge on factories, algorithms, logistics webs, industrial clockwork invisible to frontline soldiers. The bomber every 63 minutes represented the moment war became an engineering equation on planetary scale. That line between human conflict and mechanical inevitability has never fully closed since. Which leads to the final question, not addressed by any production number or casualty report. What does it mean when history becomes manufacturable? And what does it say about humanity when its greatest military triumph came not from a single battle, but from the ability to build faster than anyone else could destroy? Target length 300 to 400 words. In the end, Willow Run remains less a monument to machinery than to scale. The factory that produced one bomber every 63 minutes did not win the war alone. Soldiers crossed beaches, pilots fought through flak, sailors guarded supply routes, intelligence officers labored in shadows. Victory was assembled from millions of acts layered together. Yet something irreversible crystallized inside that Michigan plant. For the first time in history, war ceased to be governed primarily by the limits of craftsmanship or human endurance. It became governed by systems, by throughput charts, by logistics grids, by production cycles measured in minutes rather than years. Willow Run demonstrated that conflict could be industrialized to a degree where replacement overtook loss, and strategy became defined not by bravery alone, but by manufacturing velocity. This shift changed warfare permanently. From the skies above Europe to modern defense doctrine across the globe, the logic forged there still echoes that conflict is no longer just about how hard you fight, but how fast you build. Yet the human cost never vanished beneath those equations. For every statistic of output or efficiency stood young airmen stepping into uncertain skies, and workers tightening rivets knowing that each bolt secured both survival and sacrifice. The bomber every 63 minutes embodies that duality. It was proof of human ingenuity, and a reminder of human vulnerability. The machines grew more numerous than the people who flew them, but the people never became less valuable, even when the war demanded they be counted as numbers. Walking through the silent halls of Willow Run today, the absence is louder than the noise ever was. There are no lines of engines waiting for installation, no rivet guns in rhythmic chorus, no shift whistles marking time, just echoes. And in those echoes lingers a question history still quietly asks. When humanity learned to manufacture war at industrial speed, did it become stronger, or simply more capable of unimaginable loss? The answer remains unresolved. But the legacy of Willow Run stands firm, not as a tale of endless power, but as a warning engraved in steel and silence, that the limits of what we can build often outrun our understanding of what we should build.